Carry the camera, come. What we have today is projectile motion. A projectile is a body thrown up into the atmosphere and is acted upon by air resistance and acceleration due to gravity. That is, if you throw it up, it will return back. If you throw it up, it will return back and it will fall down. So everything that is thrown upward falls backward. Now, since a projectile is a body that is thrown upward, it requires initial velocity. Now, projectile motion, okay, exhibits through parabola path, hence trajectory. The next thing here is let's use b squared equal to u squared plus 2ex. Now, we can now find maximum height. We have known the time to reach the maximum height. Let us now find the expression for the maximum height. Okay, since b squared equal to u squared plus 2ax is equation of motion. Now, projectile motion has the time taken to reach the maximum height, which is 2u sine theta over g. Now, let's look at the time, the maximum height. How do we find the maximum height? Watch and see. For the maximum height, we say let v at maximum. V is always 0. Okay, 0 squared. At maximum, u becomes uy all squared. Then plus we change to minus because we are actually talking about acceleration of the body going against gravity. So we have it as negative 2g, acceleration due to gravity. Then the displacement here becomes the maximum height. Now, we've gotten the maximum height. Okay, so the expression we have to have right now is to make 2gh max the subject of the formula. So we have 2gh max is equal to uy squared. So from here, we make h max the subject of the formula by saying u squared over 2g. That means we record in equation 1 that u y is equal to u sine theta. Okay, u sine theta. And because uy is u sine theta, this implies that h max will therefore be u sine theta all squared over 2g. Okay, so that is our h max. And if that is the case, now h max therefore becomes u squared sine squared theta all over 2g. So this becomes the final expression for the maximum height of a projectile motion. Now we can move to the next stage. Motion, the two components of motion on projectile body is along y-axis and along x-axis. That is vertical component and horizontal components. These are the two motions that takes place in projectile motion. So we need to resolve u into x-axis and y-axis so that using SOHCAHTOA, okay, we have that opposite is sine theta, that is opposite all over hypotenuse, which means that uy is equal to u sine theta. Call this equation 1. Then cos theta is adjacent all over u, so that ux is equal to u cos theta, equation 2. So we need to know the motion. This is the horizontal motion and this is the vertical motion. So we need to understand in projectile motion, we just have only two directions, two motion. One, horizontal motion and vertical motion. For the vertical motion, we talk about maximum height reached. Okay, so let's relate it now to this body that is thrown vertically upward. Okay, now this is the initial velocity given to the body. This is y-axis and this is x-axis. The body is given initial velocity, okay, to be thrown vertically upwards. Okay, so there is no motion horizontally. Okay, there is motion vertically. Therefore, we have that this is the range. Okay, range. Horizontal distance is the range. Okay, horizontal distance is the range. Then this is the vertical height, maximum height reached. Okay, so from here we will be able to resolve a whole lot of things. The time to reach this point, because here we have final velocity, which is equal to 0. Okay, so the time taken to reach this point, maximum height, will be what? So we are going to find the time. But from motion, equation of motion, we have that v equal to u plus at. Equation of motion says that v is equal to u plus at. But in projectile motion, we have that final velocity is 0. Then initial velocity u. As far as it is going upwards, we have uy. The component of y is uy. The component of x is ux. So that we will now say v, which is 0. That is final velocity at maximum height. V is 0. Okay. We say at maximum height, okay, v is equal to 0 at maximum height. Now, from here, you have that 0 is equal to u. We are considering the uy. So uy, acceleration due to gravity, because as it is going upward, acceleration due to gravity is going against. Normally, acceleration due to gravity is a free fall. It falls down positively. So any other object falling down will be positive. But as long as this is going against it, it's negative. So we now say that minus a becomes g. Then t becomes the time to reach the maximum height. The time to reach the maximum height. It doesn't end there. The next thing, we already found out uy is equal to u sine theta. Uy is equal to u sine theta, which means that anywhere you see uy, you put what? U sine theta. But before then, let's imply that making gt, the solve the formula, gt will be equal to uy. Then I can say that t is equal to uy all over g. Now, what is uy? Anywhere you see uy, which is the vertical component, replace it with equation 1, which says u sine theta all over g. So this is the time to reach the maximum height. The time to reach the maximum height for the projectile body to get to the maximum height, this is the time. Now, the time taken to reach the maximum height is u sine theta all over g. Let's now take the total time of light. Total time of light. Total time of light. Okay? Total time of light is twice the time taken to reach the maximum height. So total time of light therefore becomes what? 2u sine theta over g. So that is the total time of light taken to reach the maximum height. Let's move to the next stage. Recall, we have x equal to ut. This should be better. X equal to ut plus half at squared. Okay, that has to do, we don't have anything to do with acceleration to gravity. So a, which is equal to 0, acceleration is equal to 0. So we have nothing to do with acceleration due to gravity. Okay, so everything is wiped out. Then coming down to this, we have that x becomes maximum range. X becomes range. Okay, so that from here we can now have that if x is range, then u becomes ux. Okay, u becomes ux, then multiply by t. U becomes ux multiplied by t. Now, this t is the total time of light because we are talking about the range. Okay, we're talking about something like this. This is the range. So from here to here, we're actually talking about total time of light, then the horizontal velocity, the horizontal speed. Okay, so we are considering these two. That is why we are saying these two. So if r is equal to uxt, what should we do? Very simple. First of all, you will now realize that from here, this is gone because a is equal to 0. No vertical motion. Here we are talking about horizontal motion, so we have ut. X becomes range. Okay, so from this point, we already know that ux is equal to u cos theta, and t, which is the total time of light, is equal to 2u sine theta all over g. So that if we substitute into this, you have ux becomes u cos theta into 2u sine theta, okay, over g. So from a trigonometric identity, we already know that sine 2 theta is equal to 2 sine theta cos theta. All right, sine 2 theta is equal to 2 cos theta sine theta. So from this, we have it that we can open the bracket. U times 2u will give us u squared, okay, then 2 sine theta cos theta, okay, all over g. So that from here, we would know becomes u squared. So if sine theta is 2 sine theta cos theta, therefore 2 sine theta cos theta becomes sine 2 theta all over g. So this is our range, the range of projectile motion at maximum range. What happens? At maximum range, theta is equal to 45 degrees. Theta is equal to 45 degrees at maximum range. Therefore, R is equal to U squared all over G at maximum range. Another thing we need to learn is when a body is thrown vertically upward, we say that maximum height reached, therefore, will be U squared all over 2G. Time time to reach the maximum height, therefore, will be U all over G. Then total time of flight will be 2U all over G. You need to master these solutions, these formulas. It's very, very important to note. Relationship between the range and the height. That is maximum height. Okay, so if the range is R is U squared sine 2 theta over G, then H is U squared sine squared theta over 2G. R over H will give us U squared 2 sine theta cos theta, going back again to that over G, multiplied by 2G over U squared sine theta sine theta. Okay, so from here, U squared cancel out U squared, G cancel out G, then 2 times 2 gives us 4. Okay, sine cancel out sine, cos theta over sine theta, then we have cos theta over sine theta will give us cot theta. That is 1 over tan theta. Okay, cos theta over sine theta will give us 1 over tan theta. We cross and multiply, and we have that tan theta into R is equal to 4H. All right, so tan theta is equal to 4H over R. So that theta is equal to tan inverse of 4H all over R. Tan theta is equal to 4H over R. So theta is equal to tan inverse of 4H over R. If you are given maximum height, given the range, and asked to find the angle of projection, this is the best way to find it. All right. So at this point, let's move to question and answer on projectile motion. Let's work this first question together. A projectile launched at 45 degrees with a velocity of 100 meters per second hits a target. What will be the velocity if the range is doubled? Okay. First of all, we see solution to the question. A projectile launched at 45 degrees with a velocity. The moment you see at 45 degrees, please take note, we have maximum range. So that our range is equal to U squared all over G. We do not consider this sine because sine 90 is 1. So if that is the case, we have what we call R G equal to U squared. G is equal to U squared all over R, which means this is constant. Okay? If it is constant, we now have that U1 all squared all over R1 is equal to U2 all squared all over R2. This will give us huge insight on how to solve it. If the body, what will be the velocity? Those we are looking for the U2 if the range is double. So if the range is double, so U1 all squared all over R1 is equal to, if the range is double, what is U2 all squared? Range being doubled, we have R2 is equal to 2R1. So here is 2R1. And if that is the case, so that we make U2 all squared, we solve the formula, this we cancel out this. So we have, okay, U2 all squared is equal to 2 times, then U1 is 100 meter per second. So 100 all squared. And 100 all squared will give us what? 2 times 100 all squared is 10,000. 10,000. Okay, so 2 times 10,000 is 20,000. So from here, we can now say that 2 squared is equal to 20,000. Then U2 is equal to square root of 20,000. Okay, and this will give us square root of 2 times 10 raised to the power 4, which is equal to square root of 2 times 10 raised to the power 2, which means 1.412 times 100 will give us U2 is equal to 141.2 meter per second. So this is the final solution to the question. And if this is your first time of seeing my video, like, share, and subscribe to my YouTube channel. Squeeze the camera.